Hi friends, we see something about finite element analysis. What is meant by finite element method? Actually, finite element analysis or finite element method. A finite element analysis is a numerical method for solving problems of engineering and mathematical physics. Useful for problems with complicated geometries, loadings, and material properties where analytical solutions cannot be obtained. So this is the major things we have to select the finite element analysis or method. So the purpose of finite element analysis, so analytical solution first. Stress analysis for truss, beam and other simple stresses are carried out based on dramatic simplification and idealization. Mass concentrated at the center of gravity, beam simplified as a line segment, same cross section. Design is based on the calculation results of idealized structure and a large safety factor. It will be given by experience. So FEA, design geometry is a lot more complex. The accuracy requirement is a lot higher. We need to understand the physical behavior of a complex object, strength, heat transfer capability, fluid flow, etc. To predict the performance and behavior of the design, to calculate the safety margin, and to identify the weakness of the design accurately, and to identify the optimal design with confidence. Brief history grew out of autospace industries or aerospace industries also. Post World War II, jets, missiles, space, flight's need for lightweight, structures required accurate, stress analysis paralleled growth of computers. Common IFE applications: mechanical, aerospace, civil, automotive engineering. Structural stress analysis, that is static and dynamic, linear, non-linear, fluid flow, heat transfer, electromagnetic fields, soil mechanics, acoustics and biomechanics. FEA. So FEA, discretization. So discretization means split up the huge component into number of small pieces, that is the discretization. We have two sectors, that is complex object, so material discontinuity, complex and arbitrary geometry. So real world, so simplified, that is idealized physical model, mathematical model, then discretized model, that is mesh. Another one is a simple analysis. So if you select, if you prefer anything, you have simple one and also a complex one. So simple one we can carry it out in an easiest way. Whether we prefer complex concept and complex terms, we have a number of steps to solve the process, from which we can get the somewhat exact solutions. That's why we prefer complex object, but it need more time to solve. That is the thing overcome by finite element method. That is the benefit of the finite element method. That's why we are preferring this. So first one, discretization. Model body by dividing it into an equivalent system of many smaller bodies or units, that is finite elements, interconnected at points common to two or more elements. Nodes are nodal points and are boundary lines and are surfaces. So type of finite elements. So first one, 1D, or we can simply say 1D line element. So line element is simply specified by a line. It have two ends. So the ends may be specified technically nodes. Whether the line have two nodes, so we call it as one dimensional element or link, whatever may be. Second one, two dimensional element. If we go for two dimensional, we specified as plane. It have both x and y direction. So it have more than two nodes. So that's why we call it as two dimensional. If one dimensional means it have only two nodes. If it have more than two nodes, we call it as two dimensional elements, or we can say plane element. So example for two dimensional element or 2D plane element, membrane, plate, shell, something like that. Then three dimensional element, or we can call it as three dimensional solid element. It's a closed one, closed structure. It have more than three nodes, or we can uh, say we can more than four nodes. Why? Because the one dimensional element having two nodes, two dimensional elements having three nodes, then three dimensional having more than four nodes. So that's why we call it as three dimensional elements. So temperature, displacement, stress and flow velocity, these are the things to be considered. Elements and nodes are called nodal quantity. Feature: obtain a set of algebraic equation to solve for unknown first nodal quantity, that is displacement. Secondary quantities stress and strain are expressed in terms of nodal values of primary quantity. We know very well displacements. The displacement occurs whenever we apply certain force to the body gets some change over its position or location. That's why we call it as displacement. The displacements happens only we apply the loads basis. So if the load have more than the weight of that or mass of that object, then only the object can move some distance, otherwise it won't move. So that is the things to be considered. Then secondary is the stress and strain. With application of force on that object, it have some changes in their structure. So that's why we call it as stress. So we know very well stress is internal resistance offered by the body within the elastic limit, which unit is Newton per meter square. So here force as well as area is considered. Then strain. If we applied load, the object gets some deformation. The deformation of the component to be analyzed before the application of force, then after application of force. What will be the changes in that component that should be ensured. So that is the strain. So strain is defined as, so it's a ratio between change in dimension or change in dimension by original dimension. The dimension in the sense it have length, then width and thickness, or diameter, whatever may be. Okay, so if we consider the changes in their dimensions, if we consider length, if variation in the length, we call it as linear dimension, linear strain. So linear strain is equal to change in length by original length. So each have same unit, change in length as well as the original length, they have same unit. So the units are cancelled together, so there is no unit for strain, any kind of strain. So if we consider only the length, that is the linear or longitudinal strain. So with the against length, other things to be considered as lateral strain, so or lateral dimensions. So what are the lateral dimensions means other than length means width, thickness, then diameter. So whatever may be, these things may be considered as lateral strain. So lateral strain is equal to change in width by original length, original width, or change in thickness by original thickness, or change in diameter to original diameter. These are the things to be considered as lateral strain. We should be ensure such things. So these are the things to be considered as the primary quantity, expressed in terms of primary quantity. Yeah. So the primary quantity is the displacement. So displacement means how the displacement happens means when we apply the force. So force is the primary one. So that is the primary derivative or primary quantity. So with respect to the primary quantity, we can specify the secondary quantity or secondary variables. So these things to be ensured. So these are the features among the primary as well as the secondary quantities. So these two things to be interlinked. So both of them acted like vice versa. So So both of them to be interlinked. So each have relative motion between relative things between the quantities that should be ensured.